Hello, welcome to this video. So this video will be about a conventional question in paper 1 of DSE about quadrilaterals. And the quadrilateral involving this time will be a square. So this is a square. So a square is just a regular, that means an equiangular and equilateral parallelogram. For here in particular, okay, we will have lots of parallel lines here as well. So E is upon on AD. Yes. Intersection point F is the intersection point of BD and CBD. Yes. Let G be a point such that BG is parallel to EC. F or EC. Okay. And then CG is parallel to DB. Oh, that means we have a parallelogram here as well. Good. And then part A1, triangle BCG is congruent to triangle CPS, of course, right? So just parallelogram stuff. So first of all, angle BCG equals to angle CPF. So that will be because of alternate angles. So BF, but be careful because there's so many pair of parallel lines here. So that would be because of this, right? So BCG parallel to DB. And then I will try to write CB first. So that will be common side. And then finally, so that will be this. Okay, so that will be this. At this time, okay, I will try to use this pair of parallel lines. Okay, so that would be angle CBG equals to angle BCF. So there will be alternate angles, BG parallel to EC. Good. So that's why here, referring to the diagram as well, so you can see that the two triangles will be congruent. Because of ASA. ASA instead of AAS because we included the included side. We included the included side in the proving of the congruence of triangles. So that's A1. So and then A2. So about about the similar triangles. Triangle BCF. Okay. Similar to triangle DEF. Okay, so that will be because of this. So that will be rather obvious. So first of all, again here we have another pair of parallel lines. Maybe we can use this pair of angles. Okay, so that would be angle DEF equals to angle BCF. Okay. So that will be alternate angles again. AD parallel to BC. And then if I were you, I would try to make use of the vertical opposite angles to conclude the proof. So angle DFE equals angle PFC. Vertical opposite angle. So with two pair of equal angles, we can now conclude a triangle BCF will be similar to triangle DEF. So reason will be AA. So that will be the part for part A, 4 marks. So 2 simple proofs. Okay, very good. So we have done the 2 proofs in part A. Now here comes part B, B1. So angle BCF equals angle BGC. Angle BCF, this angle equals to angle BO, this angle. Okay. So now if angle BCF equals angle BGC is given, and then according to part A1, because we have a pair of congruent triangles here, angle BGC would be corresponding to angle CFB. So that would be corresponding angles of a pair of congruent triangles. So PC, BO, so that means this angle. So that means actually the 2 sides opposite will be equal. So that's why we need to put BF equals BC equals to L because of sides opposite equal angles. So BF equals BC, CFB. Oh, I'm not wrong. So let's put this. Oh, okay, that makes sense. So this one corresponding to this, and this corresponding to this. Good. Now BF equals BC equals to L. Okay. And then DF. Okay. So if this is L, this is also L. So only for this part. Okay. So and then we need to express this part in terms of L as well. Okay, so now first of all, we try to consider the triangle DCB. And then if this is L, this is also L. And then you can see this part is L. And then we want this part. So the second is like this. Okay, so that's why here, now first of all, maybe we can use the Pythagoras theorem to find BD first. So BD would be L squared plus L squared. So that will be the square root of 2L squared, so that will be square root of 2L. And then if BD equals square root 2L, so that's why DF would be square root 2L minus the green part, so that will be minus L. So that will be part B1. Okay, going to part B1. Now here comes the last part, B2. So someone claims that AE is longer than DF. So in part B1 already we got DF, so that means okay, we now need to find AE as well. We need to find AE as well. Okay, so in part B1, so B1, this is B2. So B1, okay, we know DF equals square root 2L minus L, and BCF is isosceles, right? BCF is isosceles. And because BCF is similar to DEF, so DEF is also isosceles. So that means DE will equals to square root 2L minus L as well. And then AE, okay, AE will be equals to AD minus DE. So there will be L minus square root 2L minus L. Okay, so as a result, so that will be after removing the bracket, so there will be 2L minus square root 2L. Okay, so and then that means I will just try to compare these two. Okay, so now because 2 minus square root 2 bigger than square root 2 minus 1. So AD will be bigger than DF. So that's why the claim is agreed on. Okay, so that's all for this video. Thank you for watching.